Now we're going to talk about covalent bonding. Covalent bonding is when a bond is formed by sharing electrons. So you remember way back in the beginning when we talked about fluorine and fluorine sharing an electron? That would have been covalent bonding. So this bonding is, when we talked about polyatomic ions, this is the bonding that was happening. With phosphate was sharing electrons between all of its atoms. Phosphorus was sharing electrons with all 4 oxygens so that it had an overall charge of -3. Diatomic ions also do the same thing. Is this carbon, oxygen, oxygen atom down here? This is CO2, carbon dioxide. You see that all of these electrons right here are being shared. So that makes it a happy atom. Each atom should have 8 electrons floating around it. So again, covalent bonds, 2 atoms are sharing 1 or more of their electrons with each other. Here is your oxygen and oxygen. They share electrons so that they're happy atoms and they're filling their octet rule. So let's do a covalent bond recap. This occurs between non-metal elements. So ionic bonding was happening between metals and nonmetals. Covalent bonding happens between all nonmetals. The bonds are formed by sharing electrons. They do not produce ions because neither atom is giving anything up. They're just sharing. Some examples are O2, CO2, C2H6, H2O, and SiC. So let's do some practice. I just want to figure out if you can identify what type of bonds each of these elements have just by looking at where they're at on the periodic table and figuring out whether they're a non-metal metal bond compound, which means that they're an ionic bond, or if they're a non-metal non-metal compound, which means they have a covalent bond. So the first one here is NaCl. Looking at your periodic table, you see that sodium, Na, is in group 1, and we know that anything on the left side of the periodic table is a metal. So sodium, this is a metal. Chlorine, we can see that that is Cl. It is in group 17. It's on the right side of the periodic table, which means it's a non-metal. So this is going to be a ionic compound because it's a bond between a metal and a non-metal. The next one, this is C2H6. It's a mixture of carbon and hydrogen. And carbon, we can see that is in group 14. It's on the right side of the periodic table, which we learned, again, these are non-metals. So that means carbon is a non-metal. And if you remember from our tour of the periodic table, hydrogen is the exception to the rule. It is on the left side of the periodic table, which means it should be a metal, but hydrogen doesn't like to play by the rules, and it is actually a non-metal. Looking at your colored periodic table, you should be able to pick that out pretty quickly. And so if this is a bond between a non-metal and a non-metal, that means it's covalent. All right, looking at the next one, it's NaCO32. We know that the CO32 is a polyatomic ion, which, if you remember me saying just a little bit ago, polyatomic ions have covalent bonding. They are sharing those electrons. But if this is doing covalent bonding, but this is a metal, that means the bonding that this is producing is an ionic bond. But the bonding that this is producing is your covalent bond. On your worksheets, I don't expect you to tell me the bonding that is happening between the polyatomic ion itself. I just want to know the bonding of the whole compound put together. I just want you to know in your head that polyatomic ions are a covalent bond. So let's do some recap. Ionic bonding is the transfer of electrons. It occurs between metals and nonmetals, and atoms go from being neutral to ions. They go from not having a charge to having a charge. Covalent bonding, this is the sharing of electrons, and it happens between two metals. So no atom is giving up electrons. In reality, they're both gaining because they're sharing any unpaired or even paired electrons that they have. So this ends the lesson for today, and I hope you have a great day.